I welcome all of you who are interested in understanding this particular concept in maths. Let's look at the question. Find the formula, the nth term for the sequence 180, 60, 20, and the sequence it continues. Okay, that's the meaning of those dots there. Okay, so what is the question asking? The question is asking us to find the formula. Which formula we have to find? The nth term formula. Okay, the nth term formula for what? The question is saying for the sequence. Okay, but we know that there are two types of sequence, the arithmetic sequence and the geometric sequence. The question is not specifically telling us the type of sequence in this question, so that means that part we have to make it from our side. We have to determine whether this sequence is an arithmetic sequence or geometric sequence. Okay, for arithmetic sequence, it will have a common difference. The difference between two consecutive terms will be common. But for geometric, it will have a common ratio. So that means the ratio between two consecutive terms will be same. So let's try for arithmetic first. 60 minus 180, that will be negative 120. And 20 minus 60 will be negative 40. So it's different. So there is no common difference. So that means this is not an arithmetic sequence. Let's try for the common ratio. Okay. So what is 60 divided by 180? Common ratio T2 divided by T1. Okay. So that means 60 divided by 180. Okay. It will be 1/3. I'll just show it here. 60 divided by 180. So there it is 1/3. So that means the common ratio is 1/3. If we try 20 divided by 60, we will also get 1/3. So that means this sequence, it has a common ratio. In other words, it is a geometric sequence. 20 divided by 60. 20 divided by 60, it is also 1/3. So that means this sequence is a geometric sequence and the common ratio is 1/3. Okay, the question is asking us to find the formula, the nth term formula. So that means you need to know your nth term formula for geometric sequence. These are all the formulas in geometric sequence. Okay, the nth term formula is Tn equals AR to the power n minus 1. We will use that formula. Okay, Tn equals AR raised to the power of n minus 1. Okay, so looking at the formula, what are the components of this formula? So I can see the components of this formula are A, R, and N. We just need to examine which component will never change regardless of which nth term are we calculating. So let's look at A first. A, yes, it will never change because there's only one A. There's only one first term. This is our T1. It is also A because A is used in the formula. T2, T3. Okay, our A first term, there will only be one first term, so that means it will not change. R, there will only be one common ratio, so that means R will not change. But N will change. Okay, depends on the question. If we are calculating T5, then N will be 5. If we are calculating T4, then N will be 4. Okay, so that means we just have to look for these two variables, A and R, because they will never change, and that will make our formula for the nth term. Okay, so that means Tn equals A, the first term, A is 180, R we already calculated, it is 1/3. So that means in place of A, 180 will go there, and in place of R, 1/3 will go there. 1/3 raised to the power of n minus 1, and for any nth term. Okay, and that's it. That's the formula. So the answer is Tn equals 180 1/3 raised to the power of n minus 1. That is the formula that we have to use to calculate any nth term in this sequence. Okay, just to check if this formula is correct, let's calculate T2. The answer should be 60. Okay, this is the answer. So Tn equals 180 1/3 raised to the power of n minus 1. This is just for checking. Okay, so T2, n is 2, in place of n, 2 is there. Okay, So that means in place of n on the right hand side, 2 will go there. 2 minus 1. So 180, 1/3, 2 minus 1 is 1. 1/3 raised to the power of 1 will remain as 1/3. Bedmer's rule, exponent first, then you multiply these two. So this will give us 60. I will just show here 1/3 times 180 or 180 times 1/3 times 1/3. That will give us 60. Okay, and you can see 60 is our T2 there. So that means our formula is correct.